Today we're doing section 6.3. This is our fifth day in the section, and now we're converting equations from polar to rectangular, so kind of like the exact opposite of what we did yesterday. So for our first example, we have r equals 5. So yesterday the goal was we had x and y, and I needed to get rid of x and y and introduce r and theta. Today we're doing the opposite. Today you'll either have r or you'll have theta, or you could have both, and the goal is to get rid of that and introduce an x and a y. So if we look at all our four formulas, so let me just jot them off to the side, we have the ones from yesterday, x equals r cosine of theta, we have y equals r sine of theta, and then the two that we didn't really use yesterday are tangent of theta equals y over x, and then we had x squared plus y squared equals r squared. So all I'm given in this problem is an r, and if I want to find x and y, the only problem that's going to help me do that is this x squared plus y squared equals r squared. So I'll have x squared plus y squared equals my r, which is 5, squared. So I could say x squared plus y squared equals 25, and that's all I can do. So that's our final answer. So obviously some of these problems are going to be a little bit more involved than others, but that one is as simple as it seems. So let's try our next one. So our next one, the information given is theta equals pi over 4, and that's all you're given. So I'm going to flip back to that last screen actually so we can look at all of our formulas. So notice the first one, in order to use it, I need to have either an r and a theta to find x. For the second one, again, I need to have an r and a theta to find y. For the next one, all I need is the theta to have x and y, and the last one's x, y, and r. So if I'm only given theta and not an r, I need to use that tangent of theta formula, that equals y over x. So I'm going to use tangent of theta, and my theta is pi over 4, equals y over x. And I know the coordinate for pi over 4 is root 2 over 2, root 2 over 2. So when I find tangent of this formula, tangent of pi over 4 is equal to 1, equals y over x. And if I wanted to clean this up a little bit, I would multiply both sides by x, and I would get y equals x. And that's our final equation. And to kind of tie this together to help you understand what we're doing right now, if I graphed a pi over 4, I know pi over 4 is a 45-degree angle. It goes straight exactly in the middle. And if we want like old school graphing, I know like mx plus b, well, my y-intercept is 0, I don't have a b value, and my slope is 1. So I go up 1 over 1, up 1 over 1. So notice that this rectangular line would fall in the same place as my polar line. So let's try another one. So the third one is r equals 3 cosecant of theta. So before we're going to really work with any of the formulas, we're going to see if we can kind of manipulate this. So I know that cosecant is the reciprocal of sine, so I could change this to say 3 over sine of theta. So 1 cosecant is 1 over sine. So 3 cosecant is 3 over sine. And then I would multiply both sides by sine to kind of clear this fraction. So on the left side they cancel. So now I have r times sine equal to 3. And now I'm going to go back to those formulas. So I'm at r of sine equals 3. So if I go back to these formulas really quick, notice right here you have r of sine is equal to y. So I can say r of sine is y equals 3. So notice I've eliminated the r and the theta all in one step, and I introduced a y into the problem, and I got y equals 3. So again, all pretty easy. the last one that we're going to do is going to be the most challenging one that we have. So for the last one, our problem is r equals -6 cosine of theta. So this one's difficult because I can't manipulate this at all. R and cosine, I can't get them to be on the same side, so I can't replace it with an x. So the only thing that we're going to have to do is like a new method, and that's we're going to introduce a random r. And if I introduce something, I have to introduce it to both sides. So I'm going to multiply both sides by r. So by doing that, I get r squared equals -6 r cosine of theta. And now we're going to use, again, those formulas. So let me go back a few slides. So r squared can be replaced with x squared plus y squared. And r cosine of theta can be replaced with x. So this r squared on the left-hand side can become x squared plus y squared. And over here, this r cosine of theta can be equal to x. So now I'll have -6x. And I'm going to add this 6x over. So now I have x squared plus 6x plus y squared equal to 0. And now this is going to kind of turn into an Algebra 2 problem. So this is something that we did last year in Algebra 2 called completing the square. And there's two ways to do it. One way, people just used a formula, and the formula was b over 2 squared, and whatever that number is, you add it to both sides. Or my box people, you would take half of b, and then whatever this value is right here, that represents your c value, and you'd add it to both sides. So regardless of what method you did, my b value is 6 in this problem. So if I take half of 6 and square it, I get 9. So my box people, you would have 3 and 3 here, which would give you 9. My formula people, 6 over 2 squared is 9. So I'm going to add 9 to both sides. And the whole purpose of finding this 9 is to make this a perfect square trinomial. So if I told you to factor, my two numbers that multiply to be 9 and add to be 6 are 3. So this breaks down to be the quantity of x plus 3 squared. My box people, you can kind of see it a little bit better. See how you have an x plus 3 and an x plus 3, and that's why it becomes x plus 3 squared plus y squared equals 9. So now with this problem, you have converted it and you are completely in rectangular. So this is the most challenging one, and we'll definitely do some practice on this. And again, to kind of tie this back into what I talked about yesterday, if we're talking about our circle, the center of our circle is at -3, 0, and we would say that our radius is equal to 3. So that's just to kind of tie it all together. So we definitely will do some practice on this tomorrow. Any questions you have, please write them down so you can ask them in class.